Welcome to another video in the Linux Fundamental series. Today we are going to learn how Linux manages storage, disks, partitions, file systems, and mount points, and then use some practical commands to investigate disk space problems. Imagine a Linux server suddenly reports no space left on device. What would you check first? In this video, I will show you a simple process to identify the problem. Why storage matters. Everything we do on a Linux system eventually needs storage. The operating system, applications, databases, logs, backups, and user files all consume disk space. So understanding storage isn't just a system administration topic, it's something you will encounter regularly in Linux, DevOps, and SRE. Disk partition, file system. These three terms are often confusing for beginners, so let's separate them. Disk is the physical storage device. Partitions are a logical section of the disk. File systems are the structure that Linux uses to organize files and directories on that storage. So we can think of it as disk contains partitions and partitions can contain file systems. Linux supports many file system types. You don't need to memorize all of them at this stage. ext4 is very common in Linux systems, while XFS is widely used in enterprise Linux, particularly in Red Hat based environments. For this video, what's more important is understanding what a file system does, rather than memorizing file system names. A file system isn't useful to us until Linux makes it accessible through the directory structure. That's where mounting comes in. As an analogy, think of the file system as a room containing your data, and the mount point as the doorway through which Linux gives you access to that room. For example, a file system might be mounted at /data, and everything stored there becomes accessible under /data. Now let's move from concepts to the terminal. lsblk is one of the first commands I use when I want to understand the storage layout of a Linux system. In output we can see SDA and SDB are the disks. SDA1, SDA2, SDB1 are the partitions. The FS type is file system, for example ext4, and the mount points where it is mounted. For example, the SDA2 partition with file system ext4 is mounted on / that is root. Notice that lsblk-f gives us more information about the file system and mount points. Now suppose I want to know how much space is actually available. That's where df comes in. df-h df reports file system level disk usage, and -h makes the numbers easier for humans to read. For example, let's type df first, and we can see that the numbers are difficult to understand. But if we use df-h in the output, for example, the file system /dev/sda2 has size 25 gigabytes and use space is 12 gigabyte. The available space is 13 gigabytes. Use percentage is 48%, and it is mounted on / that is root. Which file system on the screen has the highest usage percentage? Now we know that a file system is nearly full, but df doesn't tell us which directory is responsible. That's where du becomes useful. du-sh star and sudo du -sh slash var slash star. In this command we have used sudo because this directory requires root permissions. Du helps us understand how much space individual directories are consuming. Df tells us how much space is being used. Du helps us find where it is being used. Let us investigate a large directory. Suppose log is large. We can keep drilling down until we identify the directory or files responsible for the storage usage. Finding a large file doesn't automatically mean it is safe to delete. First, understand what created it and whether it is still required. We have seen how Linux identifies storage. Now let's look at how a file system becomes accessible. Mount connects a file system to a directory, while umount disconnects it. Let's see an example. Let's create a directory /data and then identify a test partition using lsblk. We can see we have a partition sdb1 available and that is not mounted. Therefore, let's mount it. Now the /dev/sdb1 partition is mounted on directory /data. To verify, let us use df-h and ls-la slash directory name that is data. Let us unmount the file system. Let us re-verify using df-h and we can see that the partition /dev/sdb1 is unmounted from directory /data. Notice that after mounting the file system became accessible through /data. After unmounting, that file system is no longer attached to that directory. There is one more important question. What happens after we reboot? A manually mounted file system does not necessarily get mounted automatically after every reboot. Linux uses /etc/fstab file to define file systems that should be mounted automatically. To show the contents of /etc/fstab, let us use cat command. In this file, we can see that the file system is /dev/disk by -uuid and the uuid, its mount point that is / that is root, type is ext4, options are defaults, dump is 0 and pass is 1. We will cover safely configuring persistent mounts in a more advanced story lesson. For now, remember that /etc/fstab controls persistent file system mounts. There is another storage problem that can surprise Linux administrators. A file system can have free disk space but still be unable to create new files because it has run out of inodes. An inode stores information about a file such as its ownership, permissions, and other metadata. To see the inode information, the command is df-i. df-h tells us about disk capacity. df-i tells us about inode usage. This is a typical storage troubleshooting workflow. If there is no space left on the disk, first we use the df-h command to identify which file system is full. Then we use du-sh command to identify where the space is being consumed. And then we use ls-lh command to identify which files are consuming more space. Only after understanding the cause should we decide what to remove, archive, rotate, or otherwise manage. Finally, using df-h command, verify that the problem has been resolved. Let's stimulate a storage investigation. Let's create a directory and create sample files in it. Let's create another file and verify using du-sh star. We can see that two files are created, file 100 meg and file 2 200 meg. We have deliberately created some large files in a safe demonstration directory. Now we can see that which files are consuming the space. After verifying the files, we can safely remove the test directory. This is only a demonstration. In a real server, never delete files simply because they are large. These are some common storage commands. There are many storage commands, but I would like you to remember these three first: lsblk, df-h, and du-sh. lsblk tells me what storage exists. df-h tells me how much space is available. du helps me find where the space is being used. df-i gives the inode usage. Mount is used to mount file system. Umount to unmount it. And blkid gives the file system or UUID information. These are some common beginner mistakes. Mistake 1 is confusing df and du. df and du answers different questions. Mistake 2 is deleting large files immediately. A large file isn't necessarily mean unnecessary file. Mistake 3 is editing /etc/fstab carelessly. A mistake here can cause boot problems. Mistake 4 is testing on root file system. Always use a controlled lab environment when experimenting with storage. Let's bring everything together. If physical disk can contain partitions, these partitions can contain file systems, and file systems are made accessible through mount points. For every troubleshooting, remember these three commands. lsblk, what storage do I have? df-h, how much space is available? du, where the space being used? If you remember these three questions and commands, you have already learned a very useful part of Linux storage administration. We have now learned about Linux files, permissions, users, processes, services, networking, SSH, logs, cron, bash scripting, and storage. But how do all these pieces actually work together? That's what we will explore in the final lesson of this Linux Fundamental series, Linux Architecture. We will look at the shell, system libraries, Linux kernel, hardware, memory, CPU, storage, and networking, and connect them to the commands we have been using throughout this series. If you have been following this series from the beginning, congratulations. You have built a solid Linux foundation. One lesson remains: Linux architecture, where we will bring all these concepts together. I hope you will join me for the final lesson. If you found this lesson useful, please consider liking and subscribing to the channel. It helps me continue creating practical, beginner friendly IT lessons.